Hi, welcome to another Level 3 Probability Distributions video. We're going to talk about linear combinations. Now we know the mean is given a symbol mu. It's a measure of central tendency and it can be written as the expected value of x or E of x. We know the standard deviation is given the symbol sigma. It's a measure of spread and it can be rewritten as SD of x. And we know another parameter commonly used is called the variance, which can be shortened to var of x. It is equal to the standard deviation squared. All right, let's get into our example for today. The following data, we've talked about this before, is about Mr. Pythagoras' mathematics class and a test out of 6. We've converted it into a probability distribution table, and we've converted it to a probability distribution graph. We've also calculated the mean or expected value of x by taking each x value and multiplying by the probability and then adding it all up, summing it up. All right, so let's get into our next example and show you where we go from here. Mr. Pythagoras is thinking about making every question worth 3 times the points he gave everyone. What's this going to do to the mean or the expected value? So here's our distribution table, and here's our old mean or expected value of x, 3.1. We'll just put it up here for reference. So if we're making everything 3 times the value, we're going to create a new row, which is 3 times x, and we're going to times everything, all x values, by 3. Now we're going to go through and calculate the new expected value of x by multiplying each of the 3x values times the probability and then summing them all up to get our new expected value of 3x, which is 9.3. There must be a quicker way of doing this, and there is. Here's a little formula that gets provided, and let's show you what it means. We're going to work out the expected value of 3x, and all that means is we're going to multiply the old expected value of x by 3. So to work out the expected value of 3x, take the old expected value of 3.1 and multiply it by the value of a, which is the number that all values of x get multiplied by. So 3 times 3.1 gives us the new expected value of 3x, which is 9.3. That saves us having to work through the process of the table and sum everything up. All right, what about this? Instead of the idea mooted, Mr. Pythagoras wants to offer 2 bonus points for every question that the student attempted. And his class is very good and they attempted every question. What is this going to do to the mean or expected value? So once again, here's our distribution table, and here's our old mean or expected value of x, just for reference. So now we're going to take all the x values and plus 2 to every value. And once again, we're going to work through the process of taking our new x plus 2 values and multiplying them by the probability to work out the new expected value of x plus 2. And we get an expected value of x plus 2 equal to 5.1. Well, again, there's a much quicker way of doing it, and here's a little formula that gets provided. The expected value of x plus or minus b is just the same as the old expected value of x plus or minus the b. So what that means is if we add 2 to all the values of x, we just need to add 2 to the old expected value of x. So we just need to take the old value of 3.1 and plus 2 to get our new expected value of x plus 2 equal to 5.1. Which is a slightly quicker way than once again setting up the table and working through all the sums. And finally, if we combine the two ideas together, we want to find the expected value of 2x minus 1. If the old expected value of x is 3.4, well, all we're going to do in this case is we're going to multiply the old expected value by the 2 and then subtract 1 to get the new expected value. So take the old expected value of x, which is 3.4, times it all by 2. Everything's being multiplied by 2. And then we subtract 1 off it to get a new expected value of 2x minus 1 equal to 5.8. Great, thanks for watching.